So we are pleased to welcome today Maurizio Lenzerini. Maurizio Lenzerini is a professor of data and knowledge management at the Department of Computer, Control and Management Engineering of Sapienza University of Rome. And his research interests include data management, knowledge representation, automated reasoning, and knowledge graphs, with a special emphasis on issues at the frontier between data management and artificial intelligence. He is also one of the founders of the ontology-based data access and integration paradigm, which applies knowledge representation and reasoning methods to various tasks related to data modeling and management. He is the author of more than 300 publications on the listed topics and has delivered about 40 invited talks. According to Google Scholar, he has an H index of 82 and a total of almost 30,000 citations. Maurizio Lenzerini is also the recipient of, among others, 2 IBM Faculty Awards and the Pichen Award. He is a fellow of the European Association for Artificial Intelligence, of the Association for Computing Machinery, and of the Association for the Advance of Artificial Intelligence. He is an ER fellow and he is also member of the Academy of Europe. So today he will give a presentation entitled Managing Data Through the Lens of an Ontology, a journey from semantic networks to knowledge graph. Thank you.
Okay, so can you hear me?
Yes.
Okay, good. So good morning. Thank you for the introduction. So the topic of my presentation is about the relationship between data management and artificial intelligence. So I'm not assuming you are expert of these topics, and I try to be clear about it. I apologize if I will not be so. And anyway, if you have questions, I don't mind you interrupt me. I don't know, you can maybe just write on the chat or just open the microphone. Okay. So there are essentially 2 fundamental disciplines about data that are popular today. One is data analytics and one is data preparation. Or if you like, one is data science, one is data engineering, okay? So data science focuses on deliverable, available insight and knowledge from data, indispensable for many activities, right? So this is essentially data analytics. The idea is to look at the data, try to extract interesting patterns and maybe a prediction, and make prediction for various tasks. But the other discipline about the data is to manage the data. I mean, to somehow prepare the data in order to make data analytics possible. And actually, there are many studies showing that 80% of a data scientist's time is in finding, understanding, cleaning, and reorganizing data. So there are 2 essential tasks about data management. And we all know that, you know, many people talk about artificial intelligence today after the success of many interesting tasks like computer vision or recognition or many other tasks where artificial intelligence has been proved effective. And actually, artificial intelligence excels at precisely extracting insights and patterns from probably large sets of data and then making predictions based on that information. This is what people today think about artificial intelligence, also because mass media emphasize this kind of applications where AI can excel. But But artificial intelligence is something else also. I mean, there are at least two sides of this discipline. And actually, one can argue that the first soul of this discipline is not in data analytics, is not in extracting data from patterns, but is about representing the world and reasoning about the world, maybe using logic. So there are really two aspects of artificial intelligence, two schools, I would say. And if you look at the roots, if you look at the history of this discipline, you can say that probably the father of the discipline is Alan Turing. And Alan Turing was a mathematician studying mathematical logic also. So his idea of Turing machine which is at the basis of computer science, starts from trying to use logic for theorem proving. Also, there is the other side of artificial intelligence, probably starting in 1943 with the birth of neural networks, and many people associate the birth of the artificial intelligence in 1956 when this workshop, the Dartmouth conference, was held. And you find the four people organizing this starting event, I would say, the event where the term artificial intelligence has been coined. The four people are McCarthy, Miskin, Rochester, and Shannon, and essentially two of them were from the logic world, and the other, you could associate them with the other side of artificial intelligence, let's say neural networks. So, to sum up, there are two approaches to AI system. One is symbolic and model-driven, the one coming from the tradition of logic, and where the knowledge about the world is defined according to symbolic structures describing concepts and relationships, and the AI system should reason about this representation to make some tasks, to finalize some goal. And the other part is, let's say, connectionists or data-driven, where the intelligent behavior is achieved by node stimulating neurons, and the knowledge about the world emerges from the perception and the experience in the data gathered on the domain of interest. So that's another side of the AI, where you start from the data and try to induce the knowledge without the need of explicitly representing structures. Okay, so as I said, many people now associate the success of AI for data analytics, and therefore the data-driven approach is the one which is very popular today. But I argue that the other side of the AI also is very important for data preparation, for the other task that I was talking about, data preparation. Indeed, AI also excels with the other side of the discipline at representing knowledge, reasoning about knowledge, building high quality, unified, flexible, and actionable knowledge bases. Okay, and for this task, which is preliminary for carrying out good data analytics, for this task, artificial intelligence is also very important, and therefore AI for data preparation is the topic that I want to focus in the following of my presentation. So why do you really need data preparation? That's the point. Well, so the main point is that when you do data analytics, when you want to look at the data and predict some phenomenon, the main point is that this data should be of high quality. That's a key point. Otherwise, you just extract some knowledge about some data which are not, of a sufficient quality. And having good data, having good quality for data today is not so easy. It's actually very difficult. Why? Because data comes from different sources, right? Data comes from sources where data have been produced for by several applications, several people, several contexts, and therefore it is really difficult to have a coherent, conceptual, and unified view of the data, which, in my opinion, is actually a prerequisite for doing high-quality data analytics. So there are many, many reasons why this task is difficult today. I repeat that one of the problems is that data comes from distributed sources, and therefore you have to deal with redundancy, you have to deal with heterogeneity between the data, and probably also you have to deal with incoherency between data. So I want to show a very stupid example which I extract from an experience with a bank in Italy. So the fragment that you see on this slide is a fragment of just a very simple table reporting data about customers of the bank. So you see this table. You can imagine this table being structured like this. You have one tuple for each customer, and you have several attributes describing the property of the customer the bank is interested in. So, for example, you see customer code, which is an identifier of the customer. Then you have two attributes with timestamps: the starting timestamp of validity of the record, the ending timestamps of validity of the record. Then you have ID group. ID group means the ID of the group that the customer belongs to. Okay, so we are talking about customers and their relationships, and they belong into certain groups. And here, ID group is the attribute telling which is the group where the customer is. And then you have two attributes which are called flag CP, flag CF. This is a flag, which means that it's a Boolean value. If in, let's see, by the way, I will talk about the semantics of this flag, and then you have another field which is fatturato, revenue, and then we have another flag. So looking at the table and talking about the people managing this table, you realize that in the first attribute, negative values denote a holding, which is a particular kind of customer. Then you learn that the value S for the first flag means that the customer is the leader of the group it belongs to. So the S value means that that customer is the leader of the group it belongs to. The other flag means that the value S indicates that the customer is the head of the group it belongs to. Notice the leader and head are different notions. Finally, the last flag means the following. If you find in a particular record the value N, this means that the revenue field is not valid. So, do you really think this is it's a simple table? Actually, it's very simple from a superficial point of view, but knowing which is the meaning of the data and therefore how a particular task should use the data is completely difficult. It's not easy at all. It's actually a nightmare. So the point is that should we allow the user to interact with this table, or should we need a more abstract representation that specify the meaning of the data in a much more natural way? That's the key point I want to make here. And I mean, the difficulty of dealing with raw data, the data that you find, is actually so severe that people actually spend a lot of money and time to carry out data preparation and integration, because the example that I showed was just one table, but you can imagine how difficult is the task of understanding the data if you have more than one table, maybe 10, tens or hundreds. And this is actually why data preparation is still a very important task that enterprises and organizations have to address. And so that's the key point where the starting point for the proposal of a new paradigm that some years ago we and other groups of researchers proposes, the ontology-based data management paradigm. In two words, the idea of this paradigm is that instead of just looking and using directly raw data, you should somehow build a model of your data, let's say an ontology of the domain, then map the data, the raw data, to the concepts and relationships of this representation, of this conceptual model of the domain, and then trying to let the user interact not with the raw data, but with the ontology. With the, and the idea is that the user should be much more familiar with the concepts and the relationships of the domain rather than the idiosyncrasy of the source, of the data sources managed by the application. And this paradigm, which is called ontology-based data management, comes actually from the world of knowledge representation, in the sense that the techniques and the methods that you can employ to realize this paradigm comes from the research of the other side of AI, knowledge representation and reasoning. Okay, so if you apply, if you really follow this paradigm, then your system, your AI system, looks like this. You have the raw data, the data sources. You have the ontology at the top. The ontology should be a neat representation of the domain of interest rather than the data sources. Then you have the mapping, because you have to link the real data to the conceptual representation, and for this task you use the notion of mapping. I will go back to this in a second. And if you really succeed in building such a kind of architecture, then the user interacts with the ontology for its data analytics task, or for the querying task, or whatever she wants in order to access the data in a more natural way. So I try to here describe how the system could look like if you just go back to the table that I showed with the example. And now you apply the ontology-based data management paradigm. So the basic idea is that now you have the ontology. Look at the ontology. I know that, I mean, this is just a diagram, and I know that you probably don't know anything about the language used to express this diagram, but I hope and I think that you should immediately realize, even intuitively, that our domain is talking about customers. Customers belongs to groups. Holding are special customers. There are also customers with revenue, right? Some of them have revenue, others don't. They don't. And a customer that belongs to a group might be at the head of a group, or might be also a leader of the group. So even though probably you don't know anything about the formalism that I'm showing, I'm confident that you find much more easy and familiar to look at the ontology rather than the data sources that you saw before. And in order to map the data sources to the ontology, you can use this kind of statement. Okay, again, I'm relying on your intuition. And several statements, for example, it says that if you have a row in the table with a customer code U, and U is a negative value, then U is a holding. Okay, so even if you just look at one of these statements, probably you can realize that mappings are very important because they allow the link between the data and the ontology. And this is actually what, the basis for realizing services over the ontology. Because think about it, suppose a user wants to know something about the domain. It asks it expresses its requirement on the basis of the ontology language and the ontology terms. But then the user, the system should translate the service and in terms of the data sources. And if you don't have the mapping, the system cannot do that. So the mapping is actually the tool allowing the system to translate every services expressed over the ontology in terms of services over the tables where the real data, the sources where the real data are. Okay, so I don't know if you have questions. No questions? Okay. So I would like to just give you some ideas about what an ontology is. Okay, now you see here a very simple example, but which are the basic elements that we should use in order to build an ontology? An ontology is a conceptual representation of the domain of interest. Now, I think what is really important that I want to stress is that the ontology is not a description of the data. Okay, it's a description of the domain of interest. And the mapping is what links the raw data to the ontology. Okay, so which are the elements that I can use in order to build a model of my domain of interest? For this task, people have come up with ontology languages. What is an ontology language? I told you, these kind of languages come from the tradition of artificial intelligence and software engineering, and they are based on these very basic elements, concepts, which are somehow classes of objects, as I will tell you, properties of concepts that also we call attributes, relationship between concepts, right? So links between classes of objects, axioms specifying even sophisticated properties of the elements that we have introduced in the model, and then individuals and facts about individuals, because concepts are very abstract elements. But then, since they are classes of objects, the instances of this class are real individuals in the real world, and therefore we have to model also individuals and facts about individuals. And finally, an ontology language allows you also to specify queries over the ontology, right? So what is a query? It's just an expression over the language of the ontology that wants somehow to describe a requirement that the user wants an answer from. Okay? So very briefly, what is a concept? It's just an element of the ontology that denotes a collection of instances, a class. Okay? A class of objects. Actually, if you think about it, a class is so natural for human beings, right? I mean, the tradition of modeling something about classes comes from, Greek philosophers. So we are just using the notion of classification in order to build a model of the world according to what is probably the set of natural kind of structures that human beings would use. And when a concept is expressed in an ontology, you have a definition for this concept. For example, the name, the relationships with other concepts, axioms describes the instances of the concept. And then you have the instances of the concept. For example, if you have the notion of the concept of ocean, then you have the instances of this class being the single individual oceans in our world. A property for a concept is just a set of attributes that you use in order to specify properties of the instances. For example, you might have for a person eye color, which is a property of the instances of a person, right? And obviously, when you model a property of a concept, you have to say which is the name of the property and many other characteristics, like, for example, the type of values that you expect from this attribute, okay? For example, blue, brown, green, and gray could be the kind of values that you expect for the property eye color, okay? And then you have probably the most important, right, most important element of an ontology, which is the relationship. People say that the word is just a set of relations, it's not a set of facts. It's not a set of objects, it's a set of objects plus the relationship between the objects. And therefore, at the level of the ontology, at the level of the definition of the ontology, you would like to specify which are the relationship linking that are relevant in your domain for linking concepts. For example, you might introduce in an ontology the relationship work for that links an employee to the company where the employee works for, right? And so when you introduce a new relationship in the ontology, then you also expect the instances of this relationship to be relevant. And these instances are called facts. For example, that Fulvio works for a certain company, Yasi, it's a fact, which is an instance of the relationship work for. And okay, let me go back for a second to the example that we saw before. So in this ontology, customer, group, holding, and with revenue are concepts. So you expect to have these guys to have instances. For example, the instances of customer are the individual elements belonging to the class customer. Then you have properties, for example, revenue or code, and so or ID for the group. These are properties of the concept. And then you have relationship. For example, belongs to is a relationship linking customer to group. Okay. And then you have axioms. Why do you have axioms? Because look, let me go back for a second. It is not sufficient to specify that in our world we have customer and groups and belongs to. Probably you want to say more about the semantics of your domain. For example, you want to say that a customer belongs to at most one group, right? Or you want to say that a customer can also not belong to a certain group. So this is an axiom, a statement, right? A statement that should be true in the word that you are describing. And since we are using logic, I would simply say that the statement is an axiom of a theory in logic. Okay, so I will not enter into the detail, but you can imagine that you might have a logical language that expresses the semantics of your domain in terms of statement talking about the concepts and the relationship. Another example of a good axiom, of a reasonable axiom in this word, in this particular context, is that an holding must belong to a group, right? So customer cannot belong to a group, but may not belong to a group, but a holding must belong to a group. So the holding is a specific kind of customer, and for these specific customers, a stronger condition holds, and this can be expressed in terms of axioms. So, to sum up, an axiom is a logical formula that you add to the ontology, expressing condition that must be satisfied by the elements at the extensional level, by the individual that are instances of concepts and relationship. Okay. Here we have other kind of examples. For example, if you are in a context of persons, you might want to classify a person as student, engineer, philosopher, doctors, and you might want to express the relationship between these kind of classes. For example, say that a person is a student or a doctor, or an engineer, or a philosopher, right? And you might use axiom to express very sophisticated assertions on your domain. Okay. As I told you, we also have queries, right? What is a query? Now, suppose you have built the ontology, you have linked the data sources to the ontology, and now the basic service that you want to realize is to extract information from the system. And in order to do that, you can use the notion of query over the ontology. Here is an example. Suppose you want to know the revenues of the holdings that are leader of a group and is not the head of the same group. Okay? Now, this kind of requirements can be expressed in terms of a query defined in logic. Obviously, I don't want to to go into the details of the language, but probably you get an intuition that this formula that you see here is the formal definition of the requirement that I just told you. Because you see here, I want all the pairs x, y, such that x is a holding, y is the revenue of x, and there exists some z for which x is the leader of z and x is not the head of z. So this is the formal definition of a query. And the main point I want to tell you here is that this kind of query is not on the table that we saw before, is on the ontology, right? And obviously you might think of, okay, but this is very, difficult for a non-expert user. You are right. Indeed, there are, there are researchers that or system, even prototypical system, trying to just translate the natural language. I want to know the revenues of the holdings that are the leader of the group and is not the head of the same group. Translate it into the formula that you see here, so that the user, the non-expert user, can really interact with the ontology by using natural language. But the main point here is not, the language by which you express the query. The main point is that you are not expressing the query at the level of the data sources, right? It would be a nightmare for you to know all the data sources where the data are, to understand all the details of the data sources and trying to express your requirements in terms of the data sources. Rather, with the ontology-based data management paradigm, you express your requirement over the ontology, and the system, should be able to translate the query, to translate the expression into the real process that goes to the data, extract the answer, and gives you the answer. Okay, I will skip because I'm a bit late. So the main point is that the techniques, the languages, the techniques, the algorithms for doing the things that I was discussing comes from a tradition, has an history, right? Coming from the tradition of artificial intelligence, the other side of artificial intelligence, and everything started probably during the 70s of the last century, with the work by many people on semantic networks and frame-based system. Then, from this particular notion of semantic networks, many people have worked during the years, and I would say that all this line of research ended with the notion of knowledge graph today. What is a knowledge graph? I don't know, but probably you have heard about the notion of knowledge graph. For example, Google itself has, uses a knowledge graph when you search for some, when you do a search on Google. What is a knowledge graph? That, it's actually the same, probably the same thing of a semantic network. You see, if I show a semantic network in the 60s, and I show in the knowledge graph corresponding to the semantic networks, you don't see any difference, right? But there is a difference, and the final part of the presentation we'll talk about the difference. But the main point is that both a semantic network and a knowledge graph is an ontology, right? It's an ontology. You see here, you probably recognize concepts like man, person, woman, individuals like Oscar is an instance of man, links between individuals and links between concepts, right? So you see that this knowledge graph that many people talk about today, associated with the artificial intelligence, they are essentially a representation of an ontology. So we find again the idea of trying to abstract from the particular structure of the data and present the knowledge about the world in terms of knowledge structure, in terms of conceptual model. So if you look at this slide, you might think, oh, what? Come on, it's 2022. 1968, we are using the same kind of representation. What's the difference? Well, there is a big difference. And the difference is not much in terms of how you represent the word, but how can you reason about the word. In the 60s, people were just beginning to think about these knowledge structures, and they didn't have a good idea and a good background to understand how should the machine reason about the representation. Okay, but as I told you, the discipline that represents the other side of artificial intelligence is called knowledge representation and reasoning. So people in the last decades have studied not only which is a good language for representing knowledge, but also which are the algorithms for reasoning about the knowledge. And again, logic has played a fundamental role in coming up with the solution or the current solution for this problem. And if you really take reasoning seriously, then you have the possibility of realizing many other services over the ontology, services provided to the user. We just discussed one of them, which is the query answering service, but you can do a lot of other interesting things. For example, you might want to check the quality of your data at the sources, and this can be done by comparing the data with the ontology and therefore relying on the mapping. I just want to give you an intuition of how and why this can be done, and somehow how this can be done. You see the ontology at the ontology level in our example. We said before that an holding must belong to a group. You see, must belong to a group. Now, suppose that the table that I showed before for a particular holding doesn't show the group. For example, because you find in the column the value null. Now, for those who have a little knowledge about databases, knows that the value null in a certain attributes means that there is no value there. So you might come up with the idea that a certain holding in your data doesn't have a group that belongs to. Now this is a mismatch between what the ontology says about the word and what the data says about the word. So looking at the comparison between the two, you can come up with data quality problems. You might realize that your data sources is incomplete. Now, obviously, this is very important. You have to know if your data sources is incomplete or even worse, is incorrect. So comparing, and obviously then you have to decide what to do, okay, but that's another story. And that pertains to data cleaning rather than data quality checking. But my example here should convince you that you can use the ontology to check the quality of your data. Okay. I will skip this, but I want to finish my talk by saying that building a system that is really able to provide all the services that I described in terms of reasoning is not an easy task. People are still thinking about this problem. There are systems already doing some of these, but there are a lot of problems associated with the idea of realizing efficient and correct logical reasoning. Okay, so logical reasoning is not always simple. For example, I want to show this, probably funny example, talking about Italian and English that are both persons. And suppose that my axiom says that Italian are not English, right? So these two classes are disjoint. Okay. Now I know also that Italians are classified. The stereotype of Italian is classified by lazy and Latin lover. Okay, so this is disjoint and covering. So what does it mean? The axiom says that not only every lazy is an Italian and every Latin lover is an Italian, but also every Italian is either lazy or Latin lover. Then we have the English classification into gentleman and hooligan. And suppose that in my ontology, the designer, the knowledge worker, we say, has introduced another axiom that Latin lovers are gentlemen. Now, this seems like a very stupid and, a very innocuous axiom. It's just an axiom, very simple one. But look at that. Now the system, when the system reasons about the ontology, should understand that actually Italian and English are disjoint, and therefore Latin lover and gentleman are disjoint. And therefore Latin lover is an empty class. It cannot be any Latin lover. Why? Because if X is a Latin lover, then it would be both an Italian and a gentleman, and therefore an English, which is not coherent with the axiom. And therefore this ontology logically implies that Latin lover is empty and Italians are lazy. Actually, Italian coincide with the class of lazy. So you see the point here. It's a subtle kind of reasoning that the system should be able to do, and you can realize, and I think you can understand immediately that building a system that is able to do logical reasoning of this type is not only difficult from the point of view of designing, but also it's very difficult to build a system that during the lifetime of the ontology do this reasoning efficiently. Okay, so that's a very interesting line of research that is still going on. I want to skip this, and I think I'm done here. I had some other example if you want to discuss it, we could, but I want to conclude my talk with the summary. So I have talked about two sides of AI, although many people today talk about using data for extracting patterns and therefore talk about data analytics. I thought I somehow convinced you, or at least I tried to convince you, that the data preparation is as important as data analytics. And in order to do a good data preparation, people in AI have thought about a new paradigm based on knowledge representation and reasoning. So we are using the other side of AI for data preparation, and this is the ontology-based data management paradigm. I thought I hope I told you the basic idea to build the conceptual model of the world and to link such conceptual model to the data, and then trying to exploit the possibility of reasoning about the whole representation in order to provide interesting services preliminary to data analytics, for example, checking the quality of your data. As I told you, I want to finish by pointing out that this kind of research is still going on, and also that the kind of the machine learning research on machine learning is also going on. So AI, despite the fact that many mass media, want to point out that AI could solve all the problems, is still a discipline that needs a lot of research. And actually, if you look at the current research on artificial intelligence, you realize that many people are thinking of combining the two sides of AI, right? Combining both the kind of connectionist AI and the symbolic AI. It's a really exciting kind of research that is still going on and might produce interesting development in the future. Thank you for your attention.
Thank you very much. It was really clear, a very interesting talk. I don't know if there are questions on the chat or directly. Yes, Muriel.
Hi, my name is Muriel Bochu. Thank you very much for this very interesting talk. Sorry I had to join late. Let's say we are an institution of about 1,000 people at Unisanté. If we would say map our functioning, create an ontology of how our institution is organized, what would it take? I mean, from your expertise, would it take a team of 1 person, 2 person, 10 person during 1 year? I mean, let's say we start from scratch, zero, and we want really to map all the relationship, activity, expertise, income and also financial aspect, everything, just to create an ontology-based institution. What would it take from your perspective?
It's a very difficult question. So I would say no more than 20 years and at least 6 months. No, so I would say that probably after 1 or 2 meetings with you, I could answer. Okay, I cannot answer right now, because it really depends on which is the domain that you want to model, right? I mean, and I guess an organization like you could be so complex, and that you have to have a perimeter. Otherwise, probably starting modeling the world, you just come up with the Aristotle kind of ontology that whose goal was to model all the knowledge about the universe. So it's very important that you fix the perimeter. I would say, for example, okay, I want to model people, projects, expertise, publications, but I don't want to consider, for example, external collaboration with many other institutions. So I would say you have to somehow fix the perimeter. Obviously, you can always go ahead. So the nice feature of this idea is that you can probably, it's not a good idea to start with the goal of finishing and that's it. Building an ontology is a pay-as-you-go effort. You probably at the beginning you start with a certain perimeter, but then after that the system should be extensible, right? Because you just add new knowledge, and if you have done a good job in modeling, these additions should be smooth. So if you like, we can discuss, but I cannot answer. I mean,
you have answered already. Thank you.
Throw a coin and say 6 months. I don't know, but anyway, I think I understand the spirit of your question.
Thank you.
Another question? Otherwise, I understand that the selection or the modeling of the ontology is really the key aspect. And are there some ways or tools or whatever that could help, for example, to develop an ontology? Because we are working on one project, for example, we thought about developing an ontology for tobacco use, or how should we start? Or...
Okay. I completely agree with you that with the observation that once you base your system on the ontology, then the ontology becomes the critical point, right? If you really want to follow this idea, the ontology itself should be of high quality. Now, being of high quality is not an easy task to do, building an ontology, also because, to be honest, there are not many people that are really expert in modeling ontologies, okay? So it's not an easy task, but there are tools, there are some tools. To be honest, I cannot say that they are really, very effective, but if you think about it, there is, so for example, if I ask you which is a good tool for building a software system, it's probably, similar. I mean, it's a creative, building an ontology is also a creative task, because you have to good at abstracting the word and finding out the right modeling structures in order to describe your word, your domain. I think, by the way, that the key point is to build a team. And I personally don't believe too much in tools, but obviously tools are important in order to facilitate the work, but I don't believe in tools that do automatically the modeling, okay? I don't believe it. I don't believe also that there are people claiming that they have tools for building the mapping automatically. You ask me, I say, forget about it, okay? It's an effort. It's an effort that people have to do by using tools, but then the most important tool is the brain of the people, in my opinion.
Thank you. So I saw also Jean-Pierre.
Sorry, if I can add, obviously AI would help you. For example, you build the ontology and ask the system, is this coherent? That can be done. So the system could and should and is able to point out errors. Errors means something that is not logically correct. And then after knowing that, you can modify your ontology, or accept the inconsistency. In other words, AI can help you in the design process, but mostly on correcting and checking your representation, not for building it.
Yes, this is also related to my next question about the competencies that is needed, for example, in a team to develop the ontology, because it's, but you partly answer that indeed it's a teamwork to develop an ontology. So
yeah, there is a question. Can you model an ontology without having a problem in mind that you want to solve? That's a very good question. So the answer is yes, at a certain extent, in the sense that your model, your ontology should be ready to provide several services, not just one, otherwise it's not an ontology, right? But on the other hand, you should somehow ask what we call the competence questions at the beginning, right? Or after the first development of the ontology, you should pause and say, okay, let's see, which are 10, 20 questions in my system or in my context where which are important, and I would like my system to support. And this is a kind of continuous a question that you should ask yourself in order to understand whether you are missing something or not. So my answer is, the ontology should be somehow independent on the particular problem that you want to solve, but on the other hand, in order to validate the ontology, you should use some problems to understand if you are doing the correct, and it, for example, for understanding if your ontology is correct and complete. So it's a kind of yes or no answer. I don't know if I answered you. Okay.
Another question on the chat.
If you have built ontology in value domain, genomic, finance, telecom, whom with did you work? Which steps were? Okay, good. Yes, it is extremely important that you work with the expert of the domain. It's absolutely crucial. I didn't show an example of project that we in my group at La Sapienza University had with some physician in the hospital that we have in our university, Policlinico of Rome. We work jointly with physicians, in particular diabetologists. Is that the right term? Diabetologist? Okay. And because we had a lot of data about diabetes, and we had and they had a project trying to use artificial intelligence to for various tasks, for example, prediction of retinopathology, right? For example, I mean, this is just an example. So we work together for doing data preparation with the ontology-based data management paradigm. And, it was so obvious that we should have worked with our physician. So you have to have the expert of the domain. After a while, you become, a little knowledgeable about the domain, but in order to build a good quality ontology, it's crucial that you have the commitment of experts. If you don't have the commitment of experts, forget about it. So experts plus the commitment, they say, okay, we will work together. Okay, to form a team, and therefore, yeah, for example, finance or genomics, you have to build to work with the experts of the finance domain, the perimeter that you have chosen to model. I don't know if I answered the question.
Thank you very much. Then another question? No, if no, I hope that we will keep in touch for projects and other questions because we're
Sure. We still have to decide how long does it take to build your ontology. So okay.
So thank you
you
again.
Thank you very much.
Thank you.